All right, so for our third part of the reaction, we are going to be mixing our aqueous copper chloride that we created in the previous section. And we are going to be mixing that with some aqueous sodium hydroxide, or NaOH. Okay, so our lab skill in this section that we're going to focus on is measuring out the volume of liquids. So one of the things we see a lot of times when students come into chemistry is that they want to use beakers to measure out the volume of a liquid. So quick review, this is a beaker, right? It's like a cup. It is useful for mixing things, watching reactions take place, and for holding things. It is not useful for measuring the volume of something. Okay, so we needed to measure out 20 milliliters of our sodium hydroxide. So I already did that, and that is in this beaker. And if we take the camera down and put you right in front of the beaker, you should be able to see, so here are our lines, okay? And you can see that the level of this liquid, the 20 milliliters that's in here, doesn't match up very well with the 20 milliliters that is actually on the beaker. So these measurements, these numbers on a beaker are not always super accurate. So we have much more accurate ways of measuring volume than using a beaker. So we are going to show you that right now. So I've already put that 20 milliliters of sodium hydroxide into the beaker. We're going to go ahead and use that for the lab. But we also need 10 milliliters of the copper chloride solution that we created before. So we're going to go ahead and measure that out, and I will show you how we correctly measure volumes in chemistry. So you can see I've got something here called a graduated cylinder. It has very specific measurements on the side of it. So this is a 10 milliliter graduated cylinder. So it's going to be perfect for measuring our 10 milliliters of liquid. These lines in between are then, so you can see here's 8, here's 10, 9 is halfway in between. And then each of these little lines represents 0.2 milliliters, okay? We have it easy right now. We just need to fill it up to the 10 milliliter line. So I'm gonna take my copper chloride and I'm going to carefully pour it into this graduated cylinder up to that 10 milliliter line. Getting careful as I get closer, don't wanna overshoot that. Not as dire if I go past 10 milliliters in this, I can always take a little bit out. Okay, remember back when we were using the volumetric flasks, if we went over 10 milliliters, we really ran into a problem. All right, so dealing with some, whoops, see, there we go. A little bit too much, so we'll pour a little bit out back into our container here. We could also use something called a transfer pipette to make this a little bit quicker of a process. I unfortunately did not get one out before we started. All right, so we are at the correct level there. When you're measuring with a graduated cylinder, you always want to get down to table level to be able to see the meniscus. So we'll bring you down here so you can see that. If you look here, there's our 10 milliliter line, and that meniscus is the dip in the middle of the 10 milliliter line where the liquid goes down, and you can see it hits right at the top of the 10 milliliter line. If you measure from the outside part of the liquid, so over here on the side where it's a little bit higher, your measurement is not accurate. So you always want to find that dip in the middle. That's called the meniscus. Okay, so bringing you back up here so you can see the reaction. All right, so we've measured out our 10 milliliters of copper chloride. I'm gonna move this flask off to the side. We'll use that again in a little bit. I've got my 20 milliliters of sodium hydroxide here. So I am going to take this. I am going to mix them together. As I do that, you can see clearly something is happening here. All right. So we saw a color change take place. As you look, you can also see that it looks like you've maybe got some chunky stuff floating inside of that, possibly a solid. You can also see some clear spots. So I am going to get a stirring rod, not a scoopula. We never stir with a scoopula. These are only for transferring solids. So I am going to get a glass stirring rod out. Okay, looks like this. And we are going to go ahead and stir this. All right, and then let's hold it up here, see what you can see. So you'll notice as you are looking at this, you cannot see through this. So that cloudiness we saw before, it looked almost a little bit chunky. That is an indicator that we have formed some sort of solid in here, okay? So it is a solid. We've also clearly still got liquid, okay? And we've had that color change occur. So again, you're gonna wanna go back and you are going to want to look at that reaction, okay? Keep in mind, down at the bottom, you've got different states of matter. So last lesson series, you were learning about different states of matter and what that means. So that should help you identify what you've created in this beaker between looking at the reaction itself and then the states of matter. So pay special attention to that.